We introduced ConstructAid, a system for sensing, analyzing, and visualizing construction sites through photographs and 3D building information models. ConstructAid allows users to navigate construction sites in both space and time using information automatically extracted from photos and 3D building models. ConstructAid does not require time-lapse imagery. Rather, our system automatically finds and registers nearby viewpoints from unordered collections. This allows users to peer backwards and forwards in time by viewing either past images or renderings of future plans. Users can quickly annotate images with a palette of smart selection tools for architecture, engineering, and construction monitoring purposes. For example, one can indicate building components that are behind or ahead of schedule for progress monitoring, or document quality issues for communication with other teams involved in the project. These annotations are automatically transferred across views, allowing for collaborative editing, analysis, and visualization that can facilitate real-time communication and reporting among project participants and clients. Our system takes as input an unordered photo collection and a semantically rich 3D CAD model, often called a building information model. The 3D model is then semi-automatically registered to the photos through our model-assisted structure for motion procedure. The registered data is analyzed and loaded into our system where users can then navigate and assess the construction site. Here is an example dataset containing construction photos and a corresponding building information model. This data is readily available as it is common practice for field engineers, inspectors, and owners to collect many job site photos during construction. To register the model with these photos, a user provides correspondences between the 3D points in the model and 2D points in one of the images. Our model-assisted structure for motion procedure automatically registers the other photos in the collection to the model. The registered data is pre-processed to enable powerful analysis and visualization within the ConstructAid interface. First, viewpoints are clustered by location and viewing direction, and then aligned. This creates an aligned sequence of photos much like a time-lapse, allowing for temporal navigation of the construction site. This enables field engineers and inspectors to review previously collected photos of building elements and review construction sequences or better understand elements hidden within the building. View-aligned sequences can also be created from synthetic viewpoints in the 3D building model environment if enough nearby views exist. Our system also attempts to identify static and dynamic occlusions present on the site. Static occlusions are estimated by comparing the depth and normal vectors of the 3D model and the point cloud obtained via structure from motion. Differences are detected and smoothed using a variant of the cross-bilateral filter. Occlusion analysis can provide a more aesthetic view of future renderings. Dynamic occlusions are detected by locating moving objects in a view-aligned image sequence. We measure pixel-wise differences in the HSV color space, then smooth and threshold these differences to obtain a dynamic occlusion mask. These occlusions, typically construction equipment, can then either be removed or properly placed over the 3D building model for visualization. Building information models contain semantic information about the structure that our system leverages for efficient selection, annotation, and rendering. For example, building element type, group, material, and primitive can be used to select semantic regions of the model and image. Building information is simultaneously displayed to the user during selection. This strategy minimizes the need for navigation in these models to find the relevant elements. Rather, it allows the user to directly take a photo and query information from the elements in the camera viewpoint or conduct reporting in 3D directly through the 2D image interface. Selected regions can be annotated to perform progress monitoring and quality assessment. These annotations are transferred automatically to new and existing viewpoints, allowing multiple practitioners to collaborate. For example, a subcontractor can use this tool to perform daily construction reporting and share that information with the project inspector. At a later date, the inspector can capture photos of the same elements from other viewpoints and access information embedded previously or add and request additional information on the same elements. Building information models also contain material and GPS data. ConstructAid uses this data to build synthetic material and lighting models in order to create photorealistic renderings of the 3D model. New materials and lighting conditions can be applied. This is useful for residential construction where potential homeowners will be able to take photos from their desired viewpoints and review different finishing alternatives in the context of their photos, as opposed to simply viewing construction material samples. ConstructAid also works for interior construction sites and can register images with textureless surfaces, repetitive structures, and significant occlusion. Hidden or highly cluttered building systems, such as mechanical, electrical, and plumbing components, can be visualized and annotated. Components can be filtered based on visibility and type. We've also demonstrated the usefulness of ConstructAid through a pilot study with industry experts. See our paper for details.